in a randomized control trial, essentially we need three things. First of all, we need a treatment. So I've indicated that by these two cards. I've got treated in this group and control on that group. So treatment is anything you're going to do to a patient. So it could be a new drug to treat blood pressure, it could be a new form of physiotherapy, it could be a new sort of surgery, anything like that. And here's the control, or sometimes called the treatment as usual, and this is essentially the people who don't get the treatment. And what you're trying to do is decide whether the treatment works, whether the patients who get the treatment turn out to have a better outcome than the control group. So the next thing you need in a randomized control trial is a population. And I've got that, indicated this by these beads and these stones. This is the population, a heterogeneous group of patients. Some of them are beads and some of them are stones. And the third thing we need is a randomization mechanism. Now normally you should randomize using a computer, but I'm going to, for the purposes of illustration, use a pack of cards, and the randomization is simply shuffling the cards. So we need a population of people who have the disease. But it's important to remember that a randomized controlled trial is not based on a random sample from the population. Rather, it is based on a very select population. And we select this population by choosing people who don't have certain conditions. So we tend to exclude, for example, old people. We tend to exclude pregnant women. And we tend to exclude children as well. Although in the real world, these people may well get the treatment, but usually the controlled trials don't actually experiment on these. And then we also exclude people who don't consent to the trial. They're the people who refuse to join the trial. So we have a rather select population. So the next thing we need to do is to actually have an order of these populations. So we put these in a very distinct order, which we're not supposed to change. Now, the simplest thing to think about would be that patients come to a doctor's surgery with a disease, and then the doctor then decides that they're eligible for that particular trial. Or you can have the patients who are already available, and you put them into some sort of register, and then you number them strictly. And then that's the order that they will be entered into the clinical trial. So then we decide on a mechanism for randomization. And the simplest one is simple randomization. So what I've got here is the set of cards, and we're going to decide that if in fact I turn up a black card, they'll go to the control group, and if I turn up a red card, they'll go to the treated group. So now we turn over a card. And you can see it is a black card, so we put this stone over into the control group, and then they will be given the placebo or the treatment as usual. Then we turn over the next card, and it's a red card, so we then put this patient into the treated group. So we carry on doing this until we've used up the number of patients that we require. So it's fairly straightforward. Okay, so now we've got 4 in the treated group and we've got 6 in the control group. Now you can see immediately that there's one slight problem with this, and that is that you've got more in the control group than you've got in the treated group. Now normally this is not a problem, but it is much more efficient if you have the same number in the treated and the control group, and I'll deal with this later. So the important points to notice about this randomization is that there's no way of predicting in advance who is going to get the treatment and who is going to get the control. And that means that we hope that these stones in the control group roughly resemble the stones in the treated group. In other words, we've set them all from the same population, and in theory, over a long period of time, they will balance in their certain characteristics. So we've got sort of large stones and small stones, and you'd hope that the proportion of large and small would be the same in the treated and the control. And you can see in this particular situation, we only had 2 small stones, and they ended up in the control. But with a large study, you could expect that these characteristics would balance. And the very important thing here is it's not just in characteristics you know about, but also characteristics that you don't know about. So there could be something like a genetic factor in these patients, which means that they're more likely to respond to treatment than other people. But in this particular randomization, we can be sure that in the long run, for a large number of patients, we'd have roughly equal numbers of people in the treated and the control group with this genetic condition. So the next video will be say, well, how do you actually, if you knew there were some factors which predicted outcome, how can you balance for those? And how can you ensure that you have equal numbers of patients in the control and in the treated groups?